Welcome to Space Oddities. Thank you for joining us here for the launch this afternoon of the European Space Agency's new space telescope, Euclid, which is on a mission to investigate the dark universe, that is to say, dark energy and dark matter. Now, don't forget that the matter that we can see in the universe and detect and observe only makes up about 5% of the total mass and energy in the universe. So the rest of it is divided into dark energy and dark matter, both of which are entirely different, both of which do entirely different things, but neither of which we have any idea about in terms of their nature. So the Euclid mission is going to investigate all this by measuring very, very precisely the redshift of distant galaxies, that is to say, exactly how fast they are receding from us. And it's hoped that this will, if we do it for enough galaxies, that will shed a lot of light, no pun intended, on the questions of dark energy and dark matter. Dark matter, of course, is this mysterious stuff that permeates the universe. We know it's there because of its gravitational effects, but we have no idea what it is. Dark energy, on the other hand, is this mysterious force, if you like, that is making the expansion of the universe accelerate instead of deaccelerate, which was what was always presumed it was doing. Anyway, that's a long mouthful. I'm joined this afternoon by fellow Space Oddities Michael and Daz and Bernard. How are you guys?
Very well, thanks.
Lovely, thank you.
Generally good. We're going to be following the launch coverage by the European Space Agency, and you can see that on the screen here. And we'll be joining them for the launch very shortly. Any thoughts about this mission, guys?
Well, we've been waiting for a while for it because it was supposed to launch on a Russian rocket, wasn't it?
That's correct.
But unfortunately, because of all the Ukraine issues, it had to be rescheduled, and this is why we're now using a Falcon 9.
Yeah.
Good old SpaceX.
Yes, indeed.
Come to the rescue.
They're supposed to launch in 2022, a year ago. So,
but in terms of the actual launch, in terms of the actual launch itself, both the Falcon 9 and the Soyuz have an amazing reliability record.
Yeah.
So it's not as if it's going to be a better, more safer launch, if you like, with the Falcon 9, because the Soyuz that it was originally intended to launch on, of course, we know has been the Russian workhorse since the 1960s. So there we are.
Yeah. Sorry.
Go on, Michael.
I was going to say since 2000, a number of ESA spacecraft have been launched by Soyuz because of the agreements from that time.
Indeed.
But,
Yes, indeed. So the Russian Soyuz has been an amazingly reliable rocket. But then again, SpaceX's Falcon 9 has just clocked up 200 launches, I think it is. Now more than 200 launches.
It's more than that now,
and I think in that time they've had 2 failures, both right at the beginning of the program. That excludes the one that exploded on the pad when it was being fueled. But an amazingly reliable rocket. So we're hoping for a really, really good, safe launch today. Bernard, do you have any thoughts?
Yeah, the first thought, I've just realized that I've written my name and then what I do is science writing instead of science writer. The irony is all in the writing there, right? I'm going to have to recorrect that. Look, this is, again, one of these amazing missions that the European Space Agency is after Gaia and others, where, we're really trying to get hard data back in relation to these big questions that we have in the universe. And, what bigger question is than, what the hell is the universe made of? Because there's a lot of it that we seem to not know. And so
yes,
I'm really excited for this, man. Really excited for the data it's going to return and for the interpretation of the data. This might fundamentally, transform our understanding of the cosmos. So it's a fantastic mission, and I just can't wait to have it launched.
Indeed.
And I think a good comparison would be the Cosmic Background Explorer that found the
yes, indeed,
the microwave background radiation some years ago.
And it mapped it as well, didn't it?
Yeah, I think that's probably quite a good comparison to what Euclid do.
Yeah, because unlike James Webb, which is what everyone is comparing this to, which is not really, they shouldn't do. This is a different mission. This is the data that they're going to collect is not going to be made public straight away. It's going to be used initially by the scientists who have commissioned all this. It will be eventually released, but it's a dedicated. Basically, it's got one dedicated mission, and that's to map the universe, as we said. It won't be mapping all the universe. It's mapping about a third of it, I think it is, or something like that, because it's got to avoid the Milky Way, basically, or the galactic plane, and also the galactic plane, and also the solar system plane where the planets all sit, because basically there's so much dust and so much contamination there, which is reflecting so much light, it wouldn't be able to take the pictures, because this is actually using two cameras which cover both optical light and infrared, but it's also carrying a spectrograph to measure the distances and things like that. We may talk about that a bit later on.
I am personally disappointed it's only mapping a third of the universe, because anyone can do that, right?
Well, yeah.
Well, it's doing sort of two surveys. It's doing the big survey, which we all know about, but it is also mapping a smaller area, but that's going to be longer exposures to go even deeper. So it's actually doing two sorts of surveys, because with these surveys, we've seen them all before. I mean, we got things like Gaia, which is doing the same thing with the galaxy, our galaxy in the Milky Way, mapping all the stars. But we've also had, what was it? Oh, the Sloan one, but that was just the northern hemisphere, because that was a ground-based telescope. But as I said, when you do these surveys, you've got a choice. You can either go narrow but very deep, or you can go wide and not so deep. But it's all about exposure times and things like that to decide how deep you actually go back in time, because as you remember, it takes the light from these galaxies to travel to us, and that's how we look at it. So the dimmer objects we see that are further away, it's only because the light's taken so long to get to us. So
absolutely. Yes, in terms of mapping a third of the universe, I mean, Bernard's right. I mean, I remember I had once a wet weekend in Skegness where I managed to map up more of the universe than that. So, but it's obviously it's more than enough to give us a representative sample. Of course, that assumes that the universe is homogeneous, that it looks the same in all directions. And that assumption has been called into question recently, because astronomers have found structures in the universe that are much larger than the theoretical largest ones that should exist if the universe is homogeneous. So that's coming under question now as well.
Yeah, that's one of the questions they're hoping to answer, isn't it? Is all this clumpage, whether things are smooth or whether or not they, mass clumps. It's got to be a more detailed map than what we've got at the moment, and we've got some pretty good cosmic maps. So, but this is going to add to it, and I don't know how much time we've got, because as I said, this is using two cameras, one called VIS and one called NISP, NISP.
What else?
So I think that's near infrared and a spectroscopy.
Nearly had
as well.
That's what
nearly had it. Yeah. Well, it's like if you saw earlier when we were talking about what we're going to put on the show next show, and you mentioned the Tunguska. I nearly did it again. Tunguska event. You remember all the trouble I had on the astronomical alphabet?
I remember that very well.
I could say it, but when I was so tongue tied that day for some other reason, it took ages, didn't it? It was good for a giggle. So, but yeah, this is going to show us where all the matter is, and then what we're going to do is then because what we'll do, the two cameras will give us a 2D image. Sorry, I'm just trying to get my fingers in the right place. 2D image. But then what happens is then you use the spectrograph, which is also using 4 different filters at different wavelengths. And then what they will do is they'll look at the redshift, how long the light's been stretched because it's been traveling through space, plus the expansion of the universe as we know. And then what we'll do is we'll look at that, guess sort out how long this light's been traveling. We can then estimate the distance, and that will give our third dimension to be able to build the whole map. And that's basically how it's going to work. It's going to be a 2D map to begin with when they're overlaid. But then what they do is they use the spectroscopy, look at the redshift, get the distances, and that'll give us the third dimension. But also it is to look at, as you said, the dark energy. And then what we do is then you take away what we can see, the matter, and that will leave us a map of the dark matter, where all the dark matters sit in. And then, of course, as we go back in time, we'll have more and more galaxies that we can look at back in time, how they were at that time. And then we'll be able to see how the expansion has increased or decreased over time. Because since the Big Bang, we know for a while the expansion decreased, and then all of a sudden there was a massive kick, and it's been expanding faster and faster ever since. Right. So this is what this is hoping to solve.
And that kick didn't occur till about 6 billion years after the Big Bang. So 6 billion years after the Big Bang, something happened in the universe that was pretty fundamental, and the acceleration of the universe, which had been slowing down until then, started getting faster again. So we don't know what that was. Some scientists have said it's like a phase change when water turns to ice. That's what we refer to as a phase change. It changes into a different form. But we've really got no idea and why it should suddenly happen 6 billion years after the Big Bang. So, this is a really deep mystery. It's been said that dark energy is a fundamental property of space-time. It must be, because it's affecting all of the universe. This is not something that's being transmitted across the universe. It is the universe, if you like. But we have no idea what that is. So anyway, interesting times. We're now just 14 minutes or so away from launch, viewers. And if you have any questions, please don't hesitate to put them in the chat. Let's just have a quick look in the chat. And hello, Beatrice from Belgium's here. Hello, Beatrice. There we are. There's Bernard. There's your co-patriot there, Beatrice. And Michael's there. Michael's in 2 places at once. Amazing. And hello, Ian. Hello, Dean. Hello, Karen. How are you? Thank you for joining us this afternoon. We are awaiting the Bernard. No, we can't hear you.
No.
So.
Okay.
Yeah, but Bernard's been trying to say something. I've heard him.
Oh, has he?
Can you hear me now?
Yeah, but your mic is very low.
Yeah, we can hear you, Bernard.
Oh, okay. I need to.
I'll put it up a bit here. Put the level up a bit here.
Yeah, I might need to log off and come back in. I don't know if there was an issue when I joined earlier on.
No, you're okay now. Actually, I think.
Am I okay?
Yeah.
Right.
Yeah.
Okay. Cool.
Yeah. Don't you just love the internet? So we're glad to have you all with us. And if you have any questions, please don't hesitate to put them in the chat. Just to let you know, viewers, especially as we have some regular viewers here, that our T-shirts and hoodies are now available to buy. So you can be the envy of everybody on your street by sporting your very own Space Oddities gear this summer and look good in the sun. And who wouldn't want to do that? So full details will be on next week's show, on Monday's show. And apart from that, they are in a post on the. They're pinned to our Facebook group at the top of the page. So there we are. We've got lovely T-shirts available in 9 colours and hoodies available. Go and have a look, and we hope you enjoy them. And you can order them directly from a company called Skullprint, who we've used to print them. And believe it or not, Daz and Michael, they're now playing the video that I was going to play. So let's turn the sound up so we can watch this. There's a bit of background on Euclid.
The hope that we would finally understand how the universe came to be. But in recent times, the effort to define what the universe is made of has given us a very big surprise. Visible stars and galaxies make up less than 5% of the universe's total matter and energy. Beneath this visible layer is a mysterious celestial realm, consisting of shadowy particles and unknown energy fields. For decades, astronomers have puzzled at their nature, calling these elusive substances dark matter and dark energy. ESA's Euclid mission will go in search of the answer to the fundamental question: what is the universe made of? A European-designed mission, Euclid is built and operated by ESA, with contributions from the International Euclid Consortium and NASA. ESA selected Thales Alenia Space to lead on building Euclid, with Airbus Defence and Space providing the telescope and payload module. The telescope and scientific instruments form the heart of the mission. Together, they will observe billions of galaxies over more than 1/3 of the sky. Producing record quantities of data, Euclid will enable scientists to draw a precise map of the universe across space and time. This will allow researchers to investigate the effects of dark matter and dark energy on the apparent shape of galaxies and on their motion and distribution over immense distances. In turn, this will help reveal the true nature of dark matter and dark energy. The spacecraft and data communications will be controlled from ESA's European Space Operations Centre in Darmstadt. To cope with the vast amounts of data Euclid will acquire, ESA's EdgeTrack network of deep space antennas has been upgraded. These data will be analysed by the Euclid Consortium, a group of more than 2,000 scientists from more than 300 institutes across Europe, the US, Canada and Japan. Understanding the elusive nature of the universe has drawn astronomers throughout history. It remains one of the most challenging investigations in modern science, but Euclid is up to the task. The Euclid mission is a quest into the unknown, a mission to shine a light on the dark side of the universe.
Euclid is SpaceX's first mission to a Sun-Earth L2 transfer orbit, also known as the Sun-Earth Lagrange Point 2. The Sun-Earth L2 transfer orbit is nearly 1 million miles beyond Earth's orbit and a most ideal orbit for space-based astronomy because telescopes in this orbit, like the James Webb Telescope, can keep the Sun, Earth, and Moon behind them while being close enough to transmit large amounts of data to Earth and receive solar power from the Sun. Now, in order to get the rocket and payload into any orbit, the rocket has to not only go up really fast, but it also has to go sideways. As we ascend, we tilt the engines, and that turns the rocket horizontally. To help demonstrate this concept, imagine firing a cannon from a really high mountain. The cannonball will arc, and then good old gravity will pull it back down to Earth. As you increase the power, the cannonball will arc and land farther and farther away. Eventually, if you could continue to increase the power, the cannonball will end up in free fall around.
Okay, just before we go over to the final few minutes of the launch, any thoughts, guys, before the big liftoff?
Well, we just got to wait for it to lift off now. I mean, there are some statistics we can talk about, but we'll wait until the launch is. Till it's successfully launched. Let's
have a successful launch. I think that's all we can say at the
moment. Yeah. Absolutely. Yeah.
And we've lost Bernard now since we've got the gremlins in today.
Yes. Did he flounce out in a huff or something? I missed that.
No. Well, I dropped out for some unknown reason, and then the gremlins are here.
As you've
I
always
think.
been a dropout.
Yeah, I know.
Yeah.
I've got a certificate and everything to say I'm a dropout.
Yeah. Of course, SpaceX was saying that this is the first time they've first time they've launched a rocket into this to get the payload into this particular transfer orbit to L2, because of course the James Webb Telescope, which sits at L2, was launched on an Ariane 5.
Yeah.
So this is SpaceX's first attempt.
Wow.
No, let's not say the word attempt. The first time they will do it.
Yeah.
To get it into that particular orbit.
Which is good for SpaceX, and that they're doing science missions as well as communications.
Yes, absolutely. So yes, so we're now just a few minutes from the big moment. We will probably cover this until we see the first stage landing safely back on the Earth. I think that's more or less the end of the mission. I don't.
Well, unless we, I don't know how long the deployment is.
No, I was going to say, what will come first, the booster landing or the deployment? I don't know.
I think booster landing first.
Well, we'll stick around till deployment.
Oh, just sort of like just seeing that background of Michael's, just an offshoot. With the Polaris mission, do you know that when they're going, they're actually going to try and achieve the highest orbit attained
ever
by a crewed thing?
Yeah.
Does that mean that we will lose that booster off of the
I think so, yes.
Falcon 9?
Yes,
because sometimes when they kick things into a higher orbit, they lose the booster.
Yes.
Although they have been trying to land boosters now with just one engine on the ships. So maybe, I mean, we'll wait and see. We'll ask Scott when he comes on.
Yeah, absolutely.
That mission to deploy those communication satellites with the Falcon Heavy, they actually expended the boosters, didn't they?
Yes, they did.
Yeah.
So anyway, I was going to say something then. Yes, we're definitely going to cover this today till at least the deployment of the Euclid telescope. We want to see it going on its merry way, like we did with the Webb Space Telescope. That was an amazing moment when we saw the Webb Space Telescope receding into the distance with the Earth below it. And that was the last time that any humans alive today will probably ever see it, which was quite cool. So,
I mean, what was cool about that as well was the fact that it started to unfurl all its equipment just as it pulled away.
Yeah.
It was amazing. Everything was so cool with that.
You
So
can understand the
spot
telescope
on.
had been waiting for so long for that moment, and just wanted to say, "I'm free, I'm free."
Yeah, it needed to stretch.
Oh
God, that's better.
Where's that antenna?
Been sat in this box. Been sat in this box for ages.
Yeah, absolutely.
Yeah, such a relief for everybody as well.
Yeah. Okay, just over 4 minutes to go, and things are looking good at the Cape, and we see the Falcon 9 there.
I believe Launch Complex 41 rather than 39A.
Yes. You can tell by the viewing angle, can't you, actually?
Yeah.
Yes, this is at, as Michael said, Launch Complex 41. I see SpaceX are just about to start ramping up again their building work at the Cape.
Oh, right.
And they've put it on pause for a while because of their orbital launch attempt, and all their effort recently has been going into sorting out the mess after that. But they're now starting again, and the first signs of a crew tower for the Falcon at the launch complex has been seen. So similar to the other crew tower that the Dragon astronauts use. The first section of that is at the Cape, so they're going to build a second crew tower. So it's all looking good at the Cape.
This is for the Starship place, and
yeah, absolutely.
Yeah.
So it'll be a combined Falcon and Starship base. So there will be two launch pads, one for the Falcon and one for the Starship.
Yeah.
And although the sections for the Starship tower have been laying on the ground for a while, they're going to be assembling it shortly. So the second one, that's it, because they've already built one. So it's going to be really good. Then, of course, you have to ask the question: well, how will they get the Starship from Boca Chica to Cape? And of course, you could fly it, but I don't think they'll do that. Actually,
suborbital launch.
Yeah, that's right. So it's probably they're probably going to send it by bow like they do with everything else.
I don't think they get permission to fly out of Florida, would they?
No, I don't think they would. I don't think they would. Well, not
talking about. Sorry, just when they show those images from the lightning strike tower, and you're looking at the actual fairings at the top, and you're looking at the background. I love those images because you can see all the vertical assembly blocks and the other launch sites in the background. Yeah. There was one launch the other day of a Falcon 9, and they were panning round using a drone, and you could see all the famous launch sites in the background, and it was absolutely stunning.
Yeah. Right.
Yeah.
Okay, we're going to go live to the Cape now for the launch of Euclid on a SpaceX Falcon 9.
Years back in history will hopefully tell us the answer to the mystery of life, the universe, and everything.
So then really quick, when do we expect to get this data back to start really analyzing it?
Yeah, so this is a 6-year mission, and the first 3 months of the mission will actually be calibrating the data, because this is a huge feat of engineering technology. We have very, very precise images across all of the extragalactic sky, and then scientists around the world, we have 2,500 scientists in Europe and in the US across 9 data centers, will analyze these data all the way through 6 years. So our final cosmology answers will come at the end of the 6 years, but we'll do lots of exciting science along the way as well.
Carol, thank you so much. Very exciting.
Thank you.
Thanks, Megan. Thanks, Megan. We are just under 1 minute. Falcon 9 is in startup, and we are just waiting for the final go for launch.
LD, go for launch.
And great news, all systems are go for launch of Falcon 9 and ESA's Euclid Space Telescope.
T-minus 30 seconds and counting. T-minus 15 seconds and counting. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, liftoff.
Yes.
There we go.
Vehicle is pitching downrange.
Beautiful.
Lovely job.
Lovely day for me.
Beautiful day. Perfect weather.
Oh, wow.
Falcon 9 has successfully lifted off from pad 40 and throttled down to prepare for max Q, which is coming up at T plus 1 minute.
Power and telemetry nominal.
1 minute and about 12 seconds. Max Q is the highest amount of aerodynamic pressures. That's the largest structural load that the vehicle will see on ascent. We throttle down those engines just to pass through max Q, and then we'll throttle them back up once we pass through that period.
Falcon 9 is supersonic.
What a fantastic launch, guys.
Maximum dynamic pressure.
And great news, we have passed through max Q. You're getting some excellent views there on your screen. Next up, we have a few events happening back to back. That will be MECO, stage separation, and SES-1. MECO is main engine cutoff, and that's where we'll shut down all 9 of the M1D engines to slow the vehicle down in preparation for its next event, which is
MVAC chill has started.
Stage separation. And that's where the first stage separates from the second stage. Right after stage separation, the first stage will begin its journey back to Earth for landing on our drone ship, a shortfall of gravitas. And during that time, stage 2 will continue on its journey with that third event, SES-1, or second stage engine start 1. And that is where the single Merlin vacuum engine will light up and propel the second stage along with ESA's Euclid spacecraft to orbit. In addition to these three major
Wow,
events, the fairing halves will separate less than a minute after SES-1, so keep an eye out for all of those events coming up here in just about 15 seconds or so.
What a fantastic launch, guys.
What a fantastic
Yeah,
sight.
it certainly was.
Oh, that's beautiful, isn't it?
Again, coming up, we have MECO, stage separation, and SES-1.
MECO.
Main engine cut off.
Oh, beautiful. Oh, this would have been great at night.
Yeah.
Stage separation confirmed.
Hey!
Oh, there we go. Wow. Come on, ignite.
MVAC ignition.
Yes.
Yeah,
Recognition.
there he goes.
Here we go.
Some really cool views of MECO stage separation, and on your right-hand screen, you can see that the MVAC engine has
Both
ignited.
vehicles are following nominal trajectories.
Hey!
Fantastic.
On your left-hand screen, the grid fins on the first stage are deploying, and in about 15 seconds or so, we should have fairing separation.
You still see
And
it?
a very cool view from the ground.
Oh, wow. Look at that.
That's a long lens.
Oh, no. Wish I had one of them.
Me too.
Fairing separation confirmed.
And there you can
they
see
got
on your
fairing.
right-hand screen
Excellent.
that the
That's
fairing halves have deployed. Now, as I mentioned
There we go.
previously, both fairing halves are brand new and are now making their way back down to Earth and will be recovered by our recovery vessel Doug today.
Good. Yeah.
It is T plus 4 minutes into today's mission. And in order to complete today's landing, the first stage has 2 more burns left. Next up is the entry burn, and that's where 3 of the Merlin 1D engines will reignite. This helps to slow the vehicle down as it re-enters the upper parts of the Earth's atmosphere. Now that entry burn is coming up in about a couple minutes from now, and that entry burn will last about 20 seconds long. And what you're looking at on your screen, on your left-hand side is a view from the first stage vehicle, currently making its way back down to Earth, which you can see in the background.
The sun on the
And on
water
your
there.
right-hand screen is a view from the second stage,
lovely shot of
looking
it.
aft at our MVAC engine.
What the heck was this on a signal? Bermuda.
We wouldn't have had these beautiful images with the Soyuz. So,
No,
that's true.
no.
That's very
silver
true.
lining, right?
That entry burn is coming up here just about a minute and a half
Both
from now.
vehicles continue to follow nominal trajectories.
And good call-outs there.
Good news.
On the bottom of your screen, you can see the speed and altitude of each vehicle as well. And on your left-hand screen, you can see 2 of the 4 hypersonic grid fins that the first stage has. Those grid fins help guide the vehicle as it makes its way back to its landing zone. Again, today we are scheduled to land on a shortfall of gravitas, currently in the Atlantic Ocean, waiting for the first stage vehicle.
What a beautiful
And
sight.
on your screen, you're getting a great
Amazing.
view from the second stage with the MVAC there and the Earth looking amazing in the background. We're just about 20 seconds away from the entry burn on the first stage vehicle.
Absolutely wonderful.
You may see some white puffs on that first stage. That is nitrogen gas puffs for attitude control.
Stage 1 FTS has safed.
There we are.
Entry burn.
There you can see the engines have reignited
Well
on the
done,
first
Stu.
stage on your left-hand screen. This is the entry burn with 3 of 9 M1D engines reignited.
Yeah, what makes me amazed is when they
And
do
you can see
that
those
entry
engines have
burn,
shut
it's
down.
actually
That
the heat
concludes
shield as
the
well to
entry
protect
burn
the
for the first
rocket.
stage.
It's fantastic. They're using fire to fight fire.
Yeah.
Now we do
Brilliant.
have one more burn for the first stage vehicle. as it attempts to land on our drone ship, and that is the landing burn. It will just be a single engine, the Center E9 engine reigniting, and that is enough thrust to help slow down the vehicle to enable it to touch down on our drone ship. Now, during the first stage landing burn, the vehicle will be landing for its second time.
Stage 2 FTS is safe. Stage 2 terminal guidance.
The vehicle will be landing for its second time today, and just before the landing burn begins, we will also have SECO 1 on the second stage. That is second engine cutoff 1. That's where we'll shut down that MVAC engine on the second stage. This is the first of 2 burns for this mission, and that is coming up here in just a few seconds, followed by the landing burn about 20 seconds after that.
What's also amazing is how much speed is being scrubbed off that booster stage as it comes down.
Yeah.
There you can see that the MVAC engine has shut down and the landing burn has begun on the first stage vehicle.
Look at that. Shots. Wow.
Let's see if there's a bullseye.
Expected loss of signal, Kate.
Oh my god.
That's, isn't it? That's
Nominal orbit insertion.
There we go.
What an incredible clear view of Falcon 9 touching down on a shortfall of gravitas. This landing marks the second successful landing for this particular booster and marks our 204th overall successful recovery of an orbital class rocket, including both Falcon 9 and Falcon Heavy first stages. We also heard the call out for SECO 1 and confirmation of good orbit. So with confirmation of a successful second engine cutoff and first stage landing, we are going to be in a coast phase until just before the second relight of our MVAC engine on the second stage, which will be followed by payload deploy. So sit tight and we'll see you back here around the T plus 17 minute mark.
Okay then, so we got over 17 minutes for it to be deployed.
Wow. Booster landings never ever get boring, do they? That was what a clear view that was. Well, Euclid is truly on its way now. Exciting and pretty emotional stuff. It's really great watching a rocket launch with all the people that really it matters for. So remember, you can ask your questions to the experts that I've got. Just hashtag ask.
Well, there you go. What do you think, viewers?
Yeah, we'd love to have your views. I mean, from our side, it's just congratulations, Euclid, and congratulations, SpaceX. That was a faultless launch, a beautiful launch for an amazing mission. Yeah. So well done.
Yeah, so we got 17 minutes, then they're going to do a second burn on the second stage. Then they'll do the deployment. So it's a little way off. But yeah, and be on its way. It's got 3 months to be deploying and calibrating all its equipment. Literally exactly the same as the James Webb. So it's got a little way to go. But I don't think she actually answered the question when the first data dump happen, and I think it's in 2.5 years' time, which will be sort of like December 2025, if I remember right. And that's when the first dump will be done. They won't be monitoring it all the time. They would just do like they do most things now. They just do a massive dump and all the information. Then they can start working on it. So yeah, interesting times. Interesting.
Andy, we can't hear you. Your voice is not activated, Andy.
No, can't hear Andy. He's disappeared. Yeah, so yeah, that was a textbook landing. They're getting so good at this. And of course, it's all automated. And you know, it's just every time it's literally smack on the ball now. I think she said something about this was the second launch for this booster, so it's one of the newer ones.
It is. What's remarkable is of course that it's landing on a boat, and that for me, that just blows my mind every time I see one of those landing on a boat.
Yeah, of course that's automated as well. There's no people on that boat.
Yeah.
So you've got two automated machines collaborating to make the perfect landing.
Yeah.
So the whole system's absolutely fantastic.
Should we say it's robots sending robots into space? Should we start to get worried now?
Well, they keep on about AI, but we will see. We will see. But I mean, I think they're going to need AI anyway. But we got 2.5 years to sharpen it up, make sure the IQ's got the AI's got the correct IQ, and also maybe give it make sure it's got its glasses on so it doesn't make any mistakes. So something to look forward to. But like I said, this isn't a rush mission. The mission's 6 years in all, and then maybe 3 years. No, was it?
No,
I'm confused now. No, 6 years. Yeah, 6 years. And then they hopefully, if everything goes right, they should be able to expend it. They can extend it and do something else with it if they finish the actual survey.
And of course, 10 years in the making.
Michael, Andy doesn't have his mic. Andy has a technical problem with his microphone at the moment. Do you want to share with us your thoughts about the launch as well?
I just think it always amazes me to watch a launch like that. I've always been fascinated by rocket launches, and especially when we got the weather and a bright day, and the photography. The photography is amazing. I'm waiting to see the photography from the professional photographers that are around the Cape for this one.
Yeah,
Graham says, I like the brief shot of the reflection of the second stage engine on the top of the first stage.
Did you notice something come away from the engine mounting of the second stage?
Well, the MVAC engine, you were either referring to ICE, but when the MVAC engine first starts, there's a retaining an expansion ring actually around the edge of it.
Right.
Now that's actually made of cork.
Right.
So that it actually expands when they fire it up. Of course, they don't want a sudden shock cracking the bell.
Yeah.
So what they do is this band just basically holds it for a few seconds. It expands with it, and then it snaps, and that's what comes off. So
I've seen that before, but this was looked to me more like a paper ribbon coming off.
Oh, I don't know. I don't know when you're on
flexible. About. Yeah.
Yeah, I know about the expansion ring, and I did see some ice fall off and things like that from around the engines.
Yeah.
So.
I do. I mean,
I think Andy's going to reboot.
So yeah, I've always been fascinated by rocket launches.
Oh, aren't we all? Yeah.
Doing it now is just incredible. And the way
exactly it's become. I mean, what surprises me is that SpaceX are the only people really doing this. Rocket Lab are beginning to ramp up.
Yeah.
But SpaceX it's become normal now for them to do this.
And do we need to mention Blue Origin?
Sorry?
Do we need to mention Blue Origin?
Well, no, we won't go down there. But let's not ruin the day. It's just become sort of like normal for them.
Yeah.
And it's just a shame that I don't want to go into all the ifs and buts, and you know what I think about the NASA contracts and things like that. But it's just that it just goes to show that if you put your mind to it, you can do it.
Yeah.
you know, I mean, reusability is, you know, I was going to say it's not a rocket science, but it is. It, you know, they've got to go down this route. But I mean, NASA is stuck in this rut where everything's got to be expendable.
Yeah, that's right.
I mean, the SLS, they're building the new engines for it now. They're costing an arm and a leg.
Yeah.
They're no better than what the original RS-25s were.
Yeah.
And they're all going to be ditched in the sea.
Yeah.
You know,
and it's the same with Ariane 6. You know, Ariane 6 has come at the wrong time, hasn't it?
Can I come to the defense of these state-based national programs, which are Ariane 6 and SLS, and we all know that unfortunately, you know, they are also constrained by political reasons, and you know, yes, as much as we'd love to have these reusable, they're just so intricated within political you know, business models and such, and I think it's going to take a long time before they can actually, you know, go ahead. They are risk averse, and there is a reason why they are risk averse for a start, and they just don't want to try new technologies, and so they come from such a different, you know, point of view, and that it's really difficult for them to do what basically SpaceX has done.
Yeah.
Yeah, I agree with you there, Bernard. But the thing is, they don't seem to be trying to change, if you see what I mean. They've got some ideas about, I mean, virtually every country's got an idea about a reusable, like a space shuttle, a plane, which will come back. But there's no dedicated ambition to go down that road. I mean, it's like you say, a lot of it. I mean, I when you say about the political stuff and all that, a lot of it's protectionism, and because we know with the Arianes, the Europeans say basically all these satellites, military satellites, they would like to be launched on Arianes, on European rockets. Understandable. The same as the Americans, they want all their military satellites launched by American rockets, but that's why they invented ULA, one of the biggest political monopolies going, which was underfunded because it was NASA and is it Lockheed Martin?
Yeah.
All they did was just scrape off the profits and did no investment. Then, of course, we had the Russian crisis, so they lost their engines for the Atlas rockets and things like that, and now they're in dire straits. And it just seems that there needs to be some sort of like reshuffle a little bit, and let's get some thinking going. No matter whatever people, you know, somebody writes an autobiography, you think, oh, this is going to be interesting, this is going to be glorifying NASA, but 9 times out of 10, there's somewhere hidden in there criticism about the way things are done. But of course, with NASA, unfortunately, it's Congress that holds the purse strings, and they don't want things to change because it's jobs in their state. So, yeah, anyway, let's get back to talking about Euclid. We're getting away from the purpose while we're here.
So,
I mean, this is going to be... Sorry.
How long we got before the second burn?
On the what, second burn? I don't know, because Andy had the link. Oh, I haven't been counting, really. It was 17 minutes, they said, before the second burn, and then...
It's a good point. Let me since Andy's not here, he's having tech issues. Let me try and see whether I can put the link in the stream. Hold on.
Yeah. I mean, NASA spaceflight have turned themselves off.
ESA TV is still going.
Well, I think ESA, they've switched off, and then they'll be coming back just for the second burn later. But it's whether, you know, it's whether or not we want to sit and watch it. I mean, it would be nice. If we can get Andy back, then we can sort out what's going on. Because we are still live. So, but yeah, if anyone's got anything, any of our viewers have got anything to say, then what do they think? Would they like to know what dark matter is, or dark energy, or is it one of those things that you're not that sort of interested in, or something like that? It plays a very big part in what's going on, and basically what we don't understand. So I think this is going to be some science that eventually, if it works out, may hopefully solve some of our problems. And it may prove, I mean, at the end of the day, I've always said we could end up basically finding that our physics is wrong. And we may have to go back and totally rethink it. Because as we said, we've got, we've got the Hubble constant dilemma that needs to be resolved. Measured two ways, but they don't match up. So it'd be interesting what they comes back with, and if they can map the dark matter, then that'll be fantastic. I mean, the thing is, when I explained how they do it, to be honest, it's quite interesting, but it's also quite simple. So it seems like we're losing our viewers. So maybe we should knock it on the head for today. But yeah, that was a fantastic launch, and we all we can do is just wait now. When have its deployment, they'll spend 3 months moving out to L2, the Lagrange point 2, where James Webb is, and then on the way it'll deploy all its instruments. It will then calibrate them all. It's exactly like the James Webb did. And as Michael was saying, he was talking about, because these telescopes, they don't just sit in one space. The Lagrange point is a huge area. It's not a small area. It's not like one park in space and they're all trying to cram onto it. But what they have to do is they go out to the Lagrange point. They don't actually sit there. They actually orbit the Lagrange point, so that in the end, so basically what they're trying to do is keep their solar panels pointing at the sun. So they've got their heat guards and they've got their shades, or as somebody described it, as a rain shower, a roof to stop the getting wet in the rain. So they'll be out there. They're all doing their thing. There's quite a few things out there already, but they're not going to be bumping into each other. It is such a big area that they're actually sitting in. And of course, the Lagrange point is an area where everything being equal, with all the gravity pulls between the sun, planets, the Earth and the Moon and all that, is almost negligible. So it can sit there without having to adjust itself too much. And then when it does, it's got little thrusters that will just give it the minimum tweak, and then it'll keep it in its position. It's basically it's a free ride. While you're sat out there, you're not expending lots of fuel, trying to stay in the same place. So here's Andy.
That's what I was going to say as well. You know, on the Lagrange point, can they have different distances of orbits for satellites of the Lagrange point as well? So
it's because, like I said, it's not just a flat plane that you're trying to get everything into. There will be some depth to it as well. There'll be some sort of like a sphere or a cube you want to sit in to get the maximum benefit at being at the Lagrange point. And this is what I said. They're not all trying to cram into one little spot. It is a large area, and they will be, like I say, they're doing their own thing and all that. They're not getting in each other's way. And we're just so they're sat there, and like I said, they're getting in theory a free ride. They don't. They're very little. Somebody just point out Andy has turned into Bernard.
we are twins separated at birth. I don't know whether you knew that.
You can see the likeness. You can see the likeness.
It was a difficult
You got the looks, Andy.
Yeah, I got the look. He got the.
I got the brain. Yeah. Okay.
Yeah, he got the pen so he can write his books.
Yeah.
So he can write his books.
I like Gerard's comments.
Can you hear me? Okay.
Yeah, we can hear you now. Thanks.
Can you see Gerard's comments?
I'm on my microphone plan B because my microphone plan A, my main microphone, looks like it stopped working, even though the LED on it says that it is working. So I have to investigate that. Fantastic.
So Gerard knows where to look for the dark matter.
Yeah.
A point of the dark stuff. Yeah.
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 Are we nearly there yet?
No, well, how long we got? How long we've been flying? 26
Have they said?
minutes.
Have they said how long till deployment yet?
No, it was 17 minutes from shutdown of the NVAC. So I don't know how far we've got on.
Right. Okay.
I think they're just killing time.
Yeah.
Yeah, we killed some time while you were gone with some mime and some magic.
Rods.
So keep people entertained.
Andy, do you have the stream because I've been streaming.
I'm just restoring it now.
Yeah, I've used SpaceX and Sky News. Well, it's
Sky News. Sky News.
It's when I type on YouTube, live streaming. That's the first one that came up, and so I just put it on. Only
Just
to realize that it was.
I'll restore the original stream.
Yeah,
no, that's
right.
Right.
Oh. ESA's talking now.
Oh.
Yeah.
Okay.
Just 1 second.
Do you have it, Andy?
Just 1 second.
One.
Stop it.
What's the weirdest pre-launch superstition? So do you have any superstitions or launch rituals before launch?
Superstitions, okay. I think everybody will have theirs. We have traditions. We have our launch briefing the day before launch. We had it yesterday. We have our shot, the photo shot of the entire mission control team. That is very nice. And we have, of course, one of the biggest traditions here is that in the door of the main control room, we've got all the best wishes cards from all the flight control teams in the center who wish well for Euclid in the flight.
That's absolutely awesome. So many things happening in the background, and it's the day is so complicated. How do you prepare for a day like that?
Well, in a word, practice. So we've been sitting here in this configuration with these teams several times. I think 20 times we did in what we call the simulations campaign. We come here, we practice all the scenarios, nominal and off-nominal, as we call them, that we are running today. So what we see today, in principle, is already the case with the countdown. That was very good. We expect that everything is as we've seen before several times, and therefore you know what to expect, and the team is prepared for all the possible things.
Thank you very much, Thiago. That's awesome. So if you've just joined us, we're in Germany, here in the heart of the control center where they actually fly the European fleet of satellites. And you can join in at home by sending me your questions using the social media and the hashtag AskESA, as you just heard. Keep them coming and I'll try to get them answered. And as you can see, I've been joined by a theoretical cosmologist, Guadalupe Canas Herrera. I hope I haven't butchered it too much this time. Welcome to the show, and how are you feeling after that launch?
Super emotional, but also extremely grateful and thankful for everything that has done so far, so we can actually have a telescope now in space.
Yeah. So how long have you worked on the project?
So I joined the Euclid consortium back in 2018. I did my PhD preparing for this mission, and yeah, 5 years.
5 years, yeah. So it must be super exciting to see that launch. Yeah.
Wow.
Yeah.
Unbelievable.
Yeah. And so how long have scientists like you been working on this Euclid launch?
So in 2011, ESA designed the Euclid Consortium to be the scientific collaboration in charge of the exploitation and the analysis of the data. So more than a decade now, yeah.
Yeah, so I mean, in my mind, it's almost like the scientists only get to work when you get this big bundle of data. So obviously, but you've been working with them for over a decade, the scientists, and you've been working for 5 years now. So what exactly have you been, what is your role in the Euclid?
Well, you need preparation in exactly the same way that all the engineers and the fantastic team that we have here at ESOC, they have been exhaustively preparing for this moment. We also had to prepare for getting ready to analyze the data. Yeah. So we've been constructing pipelines where we're verifying that actually with the current scientific requirements, we are able to provide back what it is required from us, the goals of the mission, which is analyze the nature of dark energy and dark matter.
Yeah, so I mean, so there really is decades of work, isn't it? It's like from the beginning to when this all wraps up, it'll be several decades.
A lot of years of work, but also rewarding work, we hope.
Yeah, and of course you're really young, and so you know, this is going to be a big chunk of your career as well, isn't it?
Yeah, it was. Euclid has been part of my scientific career so far, and I expect that it will be part of my next decade.
Yeah, so that's what so things like this launch must mean just so much to you.
For us it means the beginning. Also, like the beginning of testing everything that we have been testing, and getting ready to treat ourselves with data.
Yeah. Well, one question that has come in from Twitter, I've seen quite a lot, is the images that we might get from it, because it's a survey telescope, isn't it? And therefore we're building a big map or something like that. But will we have like lovely images like James Webb gives us or Hubble gives us? Is it that kind of telescope? Will we get that?
Definitely. The quality and sharpness of Euclid image is fantastic. And actually, we hoped that after commissioning, we can provide to the society.
I think they've been listening to us.
So they can test it on their own. The quality is similar to Hubble, but the quality of Euclid is that it's able to provide us way more, wider pictures.
Yeah. So, I mean, at the end of the Euclid mission, what kind of final product do you hope to have?
The final product is the 3D map. So this is the ultimate goal. And by comparing this 3D map with our theoretical model, we expect that we can put constraints on the cosmological ingredients, the dark cosmological ingredients that we have in our universe and their nature.
Yeah, so what is so special about this 3D map, and how does it relate to geometry and dark matter and dark energy?
So the thing is that this 3D map shows how a structure has formed in our universe so far, and also because we are measuring the positions, the 2D positions of galaxies, but also the shape of galaxies and the distance, because nothing can go faster than the speed of light. Looking at these distances of galaxies is like looking at the past. So we can actually have a cosmic history view of how our universe have evolved over the years. And this is essential to test our theoretical models. Yeah,
so we've actually had an Instagram question from Christmas, Crimson or something like that on Instagram, and it cuts to the chase, I think, and it's how will Euclid be able to detect dark matter?
Yeah, so we are not a mission that will detect directly dark matter. We rely on the indirect effect that this dark matter has on the images of our galaxies by measuring the distortion on the shape of galaxies, which is really subtle, but if we have many galaxies, we can actually average over so many galaxies that the statistical certainty increase. We will be able to trace where matter is distributed in our universe. And as we know that just a tiny percentage of this matter is baryonic matter, we are potentially seeing where dark matter is.
But it is a very different problem to, say, dark energy as well, isn't it?
Yes, so it was a really poor choice of names, I have to say. Yeah, so dark matter, it is called dark because it doesn't interact with light, so it means that we cannot see it. The name dark energy is referred purely on the base that we don't know anything about it. So yeah, they are significantly different. So the idea behind dark energy is that it is this unknown substance that it is driving this accelerated expansion of our universe. As I said, we call it dark because we don't know what it is. But do you remember that I was mentioning these distances to galaxies that are gonna able to give us like some time view of the evolution of the universe? This is gonna be crucial to measure this accelerated expansion and potentially constrain dark energy.
Yeah, I've got another question actually from hashtag Ask ESA, and that's what are the potential implications or discoveries that scientists anticipate from Euclid mission, and how might they impact our understanding of the universe as a whole? And that was from Astro Mishra.
Yeah, well, we have high goals for the Euclid mission. We definitely would like to test, to actually obtain these 3 maps, so we know we have like a more exhaustive knowledge of how a structure has formed in our universe so far. That will allow us to test so many different theories, also understand better this accelerated expansion of our universe, so that we believe that it is driven by dark energy, or potentially there is like a better modified gravity theory that is allowing us to explain that. But also, yeah, we can potentially also say something about the origin of the universe as we are tracing where matter is, or even say something about some funny little particles that are called neutrinos. So yeah, Euclid will have some constraining power on that too.
And I'm going to ask my own personal question. We've got there's the crisis in cosmology, the Hubble constant being different.
Yeah.
Do you think it might actually solve
They've been
Yeah,
listening to us.
I don't know if solving, but
the
definitely
viewers,
we'll have
apparently.
something to say in here.
More information about
Yeah,
that.
the more information, the better, because we will be able to say
Just a
in
few
which
minutes to
direction
wait
and
till the
statistically
second
we're
burn.
aligned. So this
Right.
the Hubble tension is basically some tension that we have in
Just
the
gonna see if I
measurements
can
that we
find a
obtain of the
timeline
Hubble
anywhere,
parameter. That is basically a measurement of the
to
expansion
get
of
an
the
idea.
universe.
It's in the
Either we
bottom
obtain it
corner
from,
there in the red box, Andy.
measurements
It's
about
coming
the
up
origin
now.
of the universe, like really
You can
really
see it
deep
coming
in the
up.
past.
Ah, yeah,
Or
but I mean,
nowish. It
showing
seems
all
that
the
there is a
events, including
discrepancy
the
that we have to test
deployment.
experimentally. We need Euclid to put more light on this.
Yeah, well, thank you so much for giving your enthusiasm about the science of Euclid. It's an awesome mission, and you must have such good. I wish you such good luck with the in the future of
Fingers
actually.
crossed.
Fingers crossed. Yeah.
Yes.
So thanks very much for joining me. So I think it's about time that we check in with Susie Jackson now, the manager over at New Norcia, the other side of the world in Australia. There we go. So welcome back, Susie. It's not long now before your big dish, in fact, it's completely changed direction, is going to be directly pointing at our Intrepid spacecraft. Can you give us a little bit more detail about how this works and what to do next and what the next 10 minutes might look like?
Yeah, so first of all, you'll see the dish behind me will start to rise. We'll hope for acquisition of signal from the spacecraft pretty much straight away. We're tracking both the launcher vehicle, the top of the Falcon 9 rocket, in S-band, plus we're also tracking the spacecraft itself, so that we'll be able to see everything that's happening as things come over the horizon. And as soon as we've got telemetry, we'll start steering the dish here to lock onto that signal, and we'll be able to get the signal down from Euclid. And then once we get up to about 5 degrees up in the sky, we'll be able to start talking back. So we'll turn on our transmitters and we'll start sending the very first telecommands up to the Euclid spacecraft, so that we can get the testing underway and get things going.
So thank you, Susie. It's always a pleasure to hear from you, and please stay put, because we'll need you back. So we're edging ever closer to our big milestone of acquisition of signal. It's in about 4 minutes or thereabouts. But before we get there, there's the Euclid spacecraft must leave the vehicle and ready to go solo for the rest of the 1 million mile, 1.5 million kilometer journey. So we are going to go back to SpaceX and watch that happen, hopefully.
Oh, here we are. I've just seen on the web that
Again,
the
for the
deployment's
ESA
scheduled
Euclid
for
launch.
42 minutes
We've had a
after
great
launch.
mission so far, and we have just one more major milestone left in our mission, which is payload deploy. Built and operated by the European Space Agency, or ESA, with contributions from NASA and the Euclid Consortium, the Euclid spacecraft will be operated from European Space Operations Center in Darmstadt, Germany. It will explore dark matter and dark energy, which combined is known to make up 95% of the universe as we know it, and create an unmatched 3D map of the universe with time as the third dimension by observing billions of galaxies across 10 billion years of cosmic time across more than a third of the sky. The deployment is coming up here in just a few seconds.
Come on, Euclid.
Yeah.
Euclid spacecraft.
Time to say goodbye. There it goes.
There it goes.
Fantastic.
And there you can see the Euclid payload drifting away from Falcon 9's second stage.
That's
Wow.
amazing.
What a beautiful.
It's on its way.
Confirmation, we'll bring today's webcast to a close. Today's mission marked SpaceX's 243rd overall mission to date and 44th mission of this year. We want to thank the European Space Agency for entrusting us with today's mission and all of you for joining us. If you're interested in following the Euclid mission further, tune into youtube.com/ESA for more. And be on the lookout for the first images from the Euclid telescope later this fall. Thanks for tuning in, and we'll see you again soon.
Wow.
For those just joining, we are in the control.
That is just that is quite amazing.
Yeah,
absolutely.
That is.
So there we are. So the Euclid telescope is on its way to L2, which I think if the Webb telescope is anything to go by, is about a month, isn't it, to get to L2?
Yeah.
During which time they'll be calibrating all the instruments and checking out, making sure everything's okay. And we've got about 6 years to wait until we get the final results from Euclid. But there we are. Doesn't time fly when you're having fun? I'm sure it will this time.
It certainly does. I think it might actually. Let me just go through my data. I think it might be actually nearer 3 months that it takes to get out there.
Is it? Really? Because the Webb only took a month.
Yeah.
I'm trying to think now. I'm just going through what I read earlier. I think it's 3 months before it actually starts. Maybe it could be its run of photograph. So I just did notice that they what I read earlier is the first dump was in about 2.5 years' time, but they reckon we're going to be getting images
autumn, yes.
come this autumn. So that'll be interesting. So
I'll wait to see them. Anyway, viewers.
Yeah.
Viewers.
Sorry.
I don't like the sound of that word.
Viewers, we'd like to say a big thank you for joining us this afternoon. As always, thank you to our regular viewers. Thank you to a few unfamiliar names that have popped up in the chat today. So thank you all very much for being here. Thank you so much to those of you who bought us coffee. We have been Space Oddities. We have been myself, Michael, Bernard, and Daz. So thank you for being here, guys, as well. We will be back on Monday with our normal Monday evening show at 8 p.m. UK time, when we're going to be talking about the announcements this week of the gravitational wave background and the new observations of the Milky Way in neutrinos, if you like, and news of new discoveries about water on Mars. And we've got lots of other stuff lined up for you. Don't forget merchandise, t-shirts and hoodies available. Check the Facebook group. Go to our Facebook group, which is called Space Oddities, and you'll see right at the top of the page there's a pinned post with all the details of the merchandise. And we'd love to see you wearing that this summer, of course, and spreading the word, as it were. Thank you, David. Thank you for being here. Thank you, Beatrice. Thank you, Alessandro. Thank you, Ian, as always. Well, thank you, everybody who was here. Gerard, nice to see you again. And we've lost a couple who've already gone. But it was great to be with you all again. We'll see you on Monday evening as normal, 8 p.m. UK time. And from all of us at Space Oddities, have a continuing lovely weekend. Hope the weather stays kind to you. And it's goodbye from us. Say goodbye, guys.
Goodbye. Goodbye.
Bye.